Hello everyone, welcome to Equal To, and this is episode 14 of our Polynomials playlist, and we have been solving exercise, what is that again? I just forgot. Exercise 2.3, right? So in exercise 2.3 we here are at the third question. Okay, so what is the question? Let me just read it out first. Find the values of k if x minus 1 is a factor of p of x in each of the following cases. And we have 4 cases in this question. Okay, so what they mean is they have given that this x minus 1 is a factor of this p of x. For each of these cases, they have given this x minus 1 is definitely a factor. Okay, they are not asking you to find if it is a factor, they have given that it is a factor. Okay, so it's given x minus 1 is a factor. Okay, so that part is done. Now what they are asking you is you have to find the value of k. In each of these cases we have a k. Okay, all these 4 cases we have k and we are supposed to find the value for k with this given statement if x minus 1 is a factor. Now how exactly are we going to do that? Now if you have been watching and following the videos that we have already posted, you would know by now that there is something called factor theorem. Okay, so what basically factor theorem says is that if there is a polynomial x minus a that is a factor of p of x, then p of a is equal to 0. Basically I have been repeating this for the last 5-6 episodes. Okay, so basically this is what we are going to use in this question. Okay, so like we know that if x minus a is a factor, then p of a is equal to 0. Now if you put that to our situation here, we know that x minus 1 is a factor. If x minus 1 is a factor, then by using factor theorem you can say that p of 1 is equal to 0. Okay, so let me just zoom in a bit. So by using factor theorem, you can say that p of 1 is a 0. With that you are going to find the value of k. Okay, so let us just first write the value of p of 1 here in terms of k. So p of 1 is equal to 1 squared plus 1 plus k. Okay, so 1 squared is 1, again plus 1 is 1 plus k, and this we know should be equal to 0 because that is what factor theorem says. Okay, x minus 1 is a factor, so p of 1 should be equal to 0. So we have 2 plus k that is equal to 0. Okay, let me just erase this equal to, this shouldn't be there. Okay, I'm sorry, I'll just turn this off. Okay, so 2 plus k is equal to 0. Now what you're going to do, you're going to basically subtract minus 2 on both sides, or in other terms you're going to take this 2 to the other side of the equal to, so that makes it minus 2. Okay, so k is equal to minus 2. So for this case the value of k is minus 2. Okay, that is it. Nice and simple, quite easy. You are just going to use the factor theorems and solve this. Moving on to the second subdivision, I have written a lot here. Let me just erase it first. Okay, so p of x is equal to 2x squared plus kx plus root 2. Okay, again by using the factor theorem you can tell that p of 1 should be equal to 0. Okay, so 2 into 1 squared plus k into 1 plus root 2. Okay, 2 into 1 squared is basically 2 into 1 plus k into 1 is k plus root 2. That is equal to 2 plus root 2 plus k. Okay, now we know p of 1 is equal to this and that is equal to 0. So 2 plus root 2 plus k is equal to 0. With that you can tell that the value of k is equal to minus 2 minus root 2. Okay, minus 2 minus root 2, or you can also write it as minus of 2 plus root 2. Either way, anything is right. Okay, both these are right. So that is the value of k in this equation. Okay then, moving on to the next subdivision of this question. P of x is equal to kx squared minus root 2x plus 1. Again, by using factor theorem, we are going to tell that P of 1 is equal to 0. Okay, P of 1 is equal to 0. So applying value of 1 in place of x here gives you P of 1 is equal to k into 1 squared minus root 2 into 1 plus 1. So that is equal to k into 1 squared is k minus root 2 plus 1, and this we know is equal to 0. P of 1 is equal to 0. So k minus root 2 plus 1 is equal to 0. So that comes out to root 2 minus 1. Okay, root 2 minus 1, that is the value of k in this subdivision. Okay, so basically we have just added plus root 2 and subtracted minus 1 on both sides. Okay, or simply bringing these two terms to the other side. Okay then, moving to the last subdivision of this question, which is the fourth subdivision. P of x is equal to kx squared minus 3x plus k. Okay, one thing that is different in this question when compared to other questions is that we have 2 k's here. Okay, we have 2k. In the third subdivision, we only had 1k. The first subdivision and second subdivisions as well, we had only 1k. This is quite different because it has 2k. Okay, so the procedure is going to be very similar. There is nothing different in that. It's just you are going to solve it a bit differently. Okay, so basically the same process. By using factor theorem, you can tell that P of 1 is equal to 0. So P of 1 is equal to k into 1 squared minus 3 into 1 plus k value that we don't know. I am sorry, plus k. Okay, or even in the question I have written two forms of k. These are basically the same case. I'm sorry, I should have written it the same way. Okay, I'll just erase it and write it again here as well. So these are same case, these are not different values, they are the same constant k. Okay, so P of 1 is equal to 1 squared is 1, so k into 1, that is equal to k, and then 3 into 1, that is 3, and we have another k here. So P of 1 is equal to k plus k, that is 2k minus 3. Okay, now we know that P of 1 is equal to 0, right? So 2k minus 3 is equal to 0. Okay, now adding 3 on both sides or bringing this minus 3 to the other side, you get 2k is equal to 3. Okay, now with that you can say that k is equal to 3 by 2. Okay, dividing by 2 on both sides, or in other way you can tell that bringing the 2 to the other side, it becomes division. Here we have it as multiplication, so 3 by 2. Okay, so k is equal to 3 by 2, and that is the answer to the subdivision. Okay, so there is nothing really different here. We have just solved it with the same process by using factor theorem. Since x minus 1 is a factor, we know that P of 1 should be equal to 0. With that, we have found the value of P of 1 in terms of k. In this place, in this step, we have found the value of P of 1 in terms of k, because the value of P of 1 is equal to 2k minus 3. In terms of k, we have found the value, and we know that P of 1 is obviously equal to 0 because x minus 1 is a factor. That is factor theorem. Okay, so with that you can equate this to 0, P of 1, which is 2k minus 3 is 0, and with that you can easily find the value of k, which in this case comes out to be 3 by 2. Okay, so that is all for this question, and that is all for this video. If you have any doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. We'll be solving more questions from this exercise on the next video. Thank you so much for watching this one. See you in the next video. Bye for now.